Hi, welcome to this lesson on trigonometry, trig identities part 2. Let's have a look at question 1. Prove the following identity and state any restrictions in the interval 0 to 360 degrees if there are any. Okay, so I see a left-hand side and a right-hand side. The left-hand side definitely looks quite complicated because there's a tan as well and some squared terms. But the right-hand side is also a complex term, but it's a double angle formulae, which I think we could potentially simplify if we needed to. So I'm going to start with the left-hand side. So here's my proof. Start off with the left-hand side, and that's equal to cos squared beta times 1 minus tan squared beta. Now tan squared beta, so remember tan beta by the quotient identity is sine of the angle beta divided by cos of the angle beta. This is going to be cos squared beta times 1 minus. So it's going to be sine squared beta over cos squared beta, so the square term. Okay, so if I expand out that product now, I get cos squared beta minus the cos squared beta will divide into that one, and you just left with sine squared beta. But this is one of the three variations of the cos double angle. So this is cos of twice that angle, in this case beta. But that's exactly the right-hand side. So therefore, mathematically, we've shown that the left-hand side equals to the right-hand side where it is applicable for the beta values. And now we're going to actually find which beta values are not applicable, the restrictions. Okay, so the right-hand side is cos, and cos has no real restrictions. But the left-hand side, there is a tan term there. So we've got to keep cognizance of that fact that there's a tan term there. So we know that tan has asymptotes at 90 degrees. Okay, so if I think of tan beta or tan squared beta, that's tan beta all squared. Okay, that's tan squared beta. It's the same notation. Okay, so when is this thing undefined? Because then squaring it will still be undefined. So it's undefined at the asymptotes. So that's at beta equaling to 90 degrees plus k times 180 degrees. That's the period of tan. All right, so within this 0 to 360 degrees, if I put k equals 0, then beta cannot equal 90 degrees because those are the restrictions. If I put k equals 1, that's going to be 270, so beta can't equal that. K equals 2 and onwards will be outside that given restriction, and k negative values, -1, -2, will also be outside. So within that given restriction 0 to 360, I cannot put those two values in. All right, and you can actually see what I mean by this. On the right-hand side, if I took 90 degrees, then cos of 2 times 90, now that does make -1. All right, but on the left-hand side, if we did that expression, so cos of 90, and then square it, because that's cos squared, open brackets, close brackets, 1 minus, and then for tan, you're going to put open and close brackets squared, and then in those brackets, you're going to put tan of 90. Okay, so that's beta equals 90, and you see you get an error, because the calculator cannot compute tan of 90 degrees, because that's an asymptote, so it explodes all the way to positive or negative infinity, depending on left or right. Okay, so 90 degrees, definitely a restricted value. And the same thing can be said if you try plug in 270. Okay, if I plug in 270 on the left, 270 on the left, math error. Okay, it's only that when you completely simplify this expression, you end up with cos 2 beta for the values that it's actually defined on. Okay, we're not saying that it's the actual just cos 2 beta where it's all defined on. No, this original expression left-hand side, when you simplify it, becomes cos 2 beta, but there are some restrictions that are involved there. So whenever you do a proof of a trigonometric identity, it's always understood to be that is the case. It is always true for all the values that it's defined on for both the left and the right-hand side. All right, so that's how we would do this type of question. I'll see you in the next one.